So we're going to continue looking at combinations. Remember, combinations is when objects are being selected or chosen, in the order that they're chosen or selected doesn't matter. So an example of combinations is when you're playing a card game. A standard deck of 52 cards has the following characteristics. There are 4 suits: clubs, spades, diamonds, and hearts. Each suit has 13 cards. 2 of the suits are black, 2 are red. Face cards are considered to be jacks, queens, and kings because they have faces on them. Poker is a card game played from a deck of 52 cards where you get 5 cards. Question A wants to know how many different 5-card poker hands are possible. This is a combination because the order you receive those cards doesn't matter. At the end, you're going to make the best hand that you can with the 5 cards that you receive. The order that you receive them doesn't matter. So in this case, there are 52 cards. You're choosing 5. And order doesn't matter, and that's why it's C there for combinations. Right? And so you can do this on your calculator, 52 math over the probability, and number 3 in this list is NCR. So 52C5, that's how many 5-card hands are possible. 2,598,960. How many different 5-card hands can be formed that contain all diamonds or only diamonds? So because each suit has 13 cards, this means that the 5 cards have to be chosen only from the 13 that are diamonds. So that would be 13C5. Which is only 1,287. How many different 5-card hands can be formed containing 4 black and 1 red card? Well, it said above that half the cards are black, the other half are red. 2 of the suits are black, the other 2 suits are red, so that's half. So that means there's 26 black cards. And so you multiply that by 26C1, which is the number of ways you can get 1 red card from the 26 red cards that are there. All right, so we can put this into our calculator all in one step, starting with 26C4, and then that's multiplied by, got to put the 26 in first, multiplied by 26C1. So 388,700. How many 5-card hands contain 3 kings and 2 queens? Well, there's only 4 of each card in a deck. There's 4 twos, 4 threes, 4 kings, 4 queens. So the 3 kings would be chosen from the 4 kings that are in a deck, and then the 2 queens would be chosen from the 4 queens that are in the deck. So 4C3 times 4C2. Only 24 ways that you can get a hand with 3 kings and 2 queens. The last one, what about how many hands are possible with 4 aces? So that means you're going to choose all 4 aces, 4C4, but then you got to get one more card. And that card has to come from the 48 cards that are not an ace. So that would be 48C1. 4C4, 4C4 is actually 1. There's only one way you can get all four aces. And that'll be multiplied by 48C1. Which is 48. So that gives us 48 different hands. Which, if you think about it, makes sense. Right? You could have all four aces and a 2. And there are 4 different 2s you can get. So that's 4 possibilities. You can have all 4 aces and a 3. And there are 4 3s. So now you're up to 8 possibilities. And so on. A bag contains 7 black balls, 6 red balls. And how many ways can you draw groups of 5 balls if at least 3 must be red? So at least 3. So you're going to collect 5 altogether, and at least 3 of them must be red. So if we write down the different scenarios that are possible here, you could have 3 red, and that means 2 black, because you're only drawing 5. Or you could have 4 red. The word at least means that many or more. And then you'd have 1 black to give you a total of 5. Or you could have all 5 red, which means no black. Each of these scenarios represents at least 3 red. At least means that many or more. So you're going to select 3 red from the 6 that are there. And again, order doesn't matter, so it's just combinations. Remember, the word and means to multiply, so you're going to multiply that by 7C2, because that's the number of ways you can get 2 black balls from 7. Remember, or means to add. 4 red would be 6C4, and 1 black would be 7C1, or, again, add. 5 red, meaning you're getting all the balls, from the 6 red balls. And if you wanted to, you could say multiply that by 7C0, meaning you're not selecting any balls from the 7 black. But 7C0, we're going to see, is 1. And that's why you don't necessarily have to have that times 7C0 there, because 7C0 is 1. And multiply by 1 doesn't change anything. Okay. So 6C3 times 7C2 gives us 420. So that's how many 5-card hands are possible with 3 red and 2 black cards. Plus 6C4 times 7C1 105 plus, and as I said, we only need really 6C5 there, which is 6. So you add these 3 together, you'll get 531. So there's the answer for that one. Number 3, express that as factorials and simplify. So NC5, to do this, you're going to use the NCR formula, which is on the formula sheet, but it says that NCR is n factorial over n minus r factorial times r factorial. Remember, with permutations, there's no extra factor of r factorial on the bottom. That's the difference between the two. These formulas are given to you on the formula sheet. Don't have to remember them. They'll be given to you. All right, so NC5 would be n factorial over n minus 5 factorial times 5 factorial. and that is divided by n minus 1c3. So it'll be n minus 1 factorial over, now remember the denominator has two factors in it. The first one is the difference between n and r, right? It's n minus r factorial. And in this case, the expression that's in the n position is n minus 1. But then you have to subtract r as well. And then you have that extra factor on the bottom of r factorial. So let's just simplify that second term. So the first one is n factorial over n minus 5 factorial times 5 factorial. And I'm going to start simplifying this expression by changing the division to multiplying, right? To divide by a fraction, multiply by the reciprocal. So the denominator, which will become n minus 4 factorial times 3 factorial, will go on top. And on the bottom, it'll be my n minus 1 factorial. So this is what I now need to simplify. All right, so if I can get factors that are the same on the top and the bottom, either directly on top of each other or diagonally across from each other, we can cancel. So that's what we need to do. We need to get some factors that are the same on both the top and the bottom. If I take this n factorial and expand it, the next term after that would be n minus 1, which the denominator on the other side is n minus 1 factorial. So that's my first step. I'm going to take the n factorial and expand it to n minus 1, and we could go on forever, but we're stopping at n minus 1 and putting a factorial in the bottom because I have an n minus 1 factorial on the bottom of the second part. All right? If I take this n minus 5 factorial on the bottom and I expand that, the next one will be n minus 6, then n minus 7, then n minus 8. Not going to help us. Right? However, if I take this n minus 4 factorial on the top right, I can expand that one. My first term would be n minus 4. My next term would be n minus 5. You're always getting smaller as you go. And I put a factorial on that one because that'll cancel with the n minus 5 factorial on the bottom left. Brighton, do you have gas or a question? Because you got this look on your face. I'm hoping that it's a question. Did you look at the videos? Okay. So which part are you looking at? Are you looking at this part right there? Well, this is the formula, and it was in the notes. Like this is the formula we're using right there. Well, n refers to what's in front of the c. So n factorial on top, and n is there. That's what is in front of the c, which for this top part is just n. After the c is your r. On the bottom part, the expression that's in the n position is n minus 1. That's what's in front of the c. R is what's after the c. Minus 3, yep, which is right there. Okay? All right. I'm here to help. Pardon me? Right. Okay, where was I before I was so rudely interrupted? I know you're not, but that's okay. All right, this 5 factorial on the bottom, I'm going to expand that as well. It'll be 5 times 4 times 3, and you can go all the way down to 2 times 1. However, I've got a 3 factorial up here. If I expand the 5 factorial, it'll be 5 times 4 times 3 factorial. And then that 3 factorial counts with the 3 factorial on the top right. So I don't think I've missed anything here. I think I've accounted for everything. Yep. So now I'll cancel. N minus 1 factorials cancel. N minus 5 factorials cancel. And 3 factorials cancel. So we are left with n bracket n minus 4 on top over 5 times 4, which is 20 on the bottom. And it's simplified. And you could check to make sure that the expression you have at the end is equal to what you started with by choosing any value of n that you wanted to. But remember, n has to be greater than or equal to the r values, because n refers to what you're choosing from. Grab that there too. Right? R is how many you're choosing, n is how many you're choosing from. Well, you can't choose more than what you have to choose from. So because of that, n has to be greater than or equal to r. So what I mean by saying that is, if you want to check, you'd have to use an answer or a value of n greater than or equal to 5, because 5 is the greatest r value we have to work with in this expression. So let's choose n equals 6, just as a check. Let n equal 6. So the original expression would be 6c5, and that is divided by, when n is 6, n minus 1 would become 6 minus 1, or 5c3. So 6c5 divided by 5c3 is that value, 0.6. We're going to check it against the answer that we got when we simplified it, which was n bracket n minus 4. And remember, we said n is going to be 6. So it's going to be 6 times, and when you let n equal 6 in the n minus 4, that'll be 2. So it'll be 12 divided by 20. 6 times 2 divided by 20. So 12 over 20, same value. Thank you. So it checks. Okay, it checks. We saw questions like example 4 using permutations, where you're asked to solve them algebraically, because you can just use guess and check on your calculator to find out what n is. You can do that. But it says solve algebraic, which means you have to show your work. So NC2 is n factorial over n minus 2 factorial times 2 factorial. That has to equal 21. And I'm going to simplify. I'm going to expand the n factorial. The next term will be n minus 1. The next term will be n minus 2, which is where I'm going to stop and put a factorial on the end, because I've got an n minus 2 factorial on the bottom. The other thing I'm going to do is I'm going to multiply both sides by 2 factorial, which is just 2. 2 times 1. So the 21 becomes 42 when you multiply both sides by the 2 factorial, or 2. N minus 2 factorials cancel. So we're going to have n squared minus n equals 42. And to solve a quadratic, we always make it equal to 0. And then we factor. This will be n minus 7, n plus 6. So therefore, n can only equal 7. Negative 6 is extraneous, because, again, n refers to the number of items you're choosing from. You can't choose from a negative value or a negative number of items. And we can check this in our calculator. What is 7c2? It does equal 21, so it checks. Question B. I'll have 2 times nc2, which would be n factorial over n minus 2 factorial times 2 factorial. Right? That 2 in front is the same as 2 over 1. Only the top gets multiplied by 2, not the bottom. And that must equal n plus 1 c3, which would be n plus 1 factorial, over n plus 1 take away 3 factorial times 3 factorial. In this case, I will cross multiply. When you cross multiply, you have 2n factorial times n plus 1 take away 3 is n minus 2 factorial times 3 factorial. And that must equal, the other cross product is n plus 1 factorial, n minus 2 factorial, and then 2 factorial. So I cross multiplied. Whenever you have two ratios that are equal to each other, the cross products are equal. So now we look at these, and the first thing you should recognize is you can divide both sides by n minus 2 factorial. They cancel. Now, I got to look and see what else I'm going to expand. I'm not going to expand the n factorial. See, on the other side, I have an n plus 1 factorial. If I expand n factorial, the first term is n, the next one is 1 less, n minus 1, then n minus 2, then n minus 3. You're never going to get to n plus 1 factorial. However, I can expand the 3 factorial. That'll be 3 times 2 factorial. And that 2 factorial will cancel with 2 factorial on the other side. And on the right side, the n plus 1 factorial can be canceled, or expanded, I should say. So the first term is n plus 1. The next one is 1 less, which is n. And I'm going to put a factorial on that because I have an n factorial on the left side. That now will cancel with that. So n factorials cancel. 2 factorials cancel. So we are left with, on the left, 2 times 3, which is 6, equaling n plus 1. So n will equal 5. So there's our answer that we got. This one would be quite a little, well, I shouldn't say that. Take a bit more time to do it by guess and check, but it could definitely be done by guess and check. So if we check it though, 2 times nc2 when n is 5. So the left side works out to be positive 20. On the right side, when n is 5, it'll be 5 plus 1, which is 6c3. Same number. Okay, so it checks. During a Pee Wee hockey tryout, all the players met on the ice after the last practice and shook hands with each other. How many players attended the tryouts if there were 300 handshakes in all? So in this case here, what you have to realize is that it takes 2 players to come together to shake hands. Okay? What this is saying is that NC2 equals 300. That's what it's saying. And so NC2 would be n factorial over n minus 2 factorial 2 factorial. And again, that needs to equal 300. So n factorial is what we're going to expand, because the next term would be n minus 1, and then n minus 2, which will stop, and put a factorial on the end because we have an n minus 2 factorial on the bottom. The other thing I'll do is multiply both sides by 2 factorial, or 2, which gives us 600 on the right. So the n minus 2 factorials cancel, and we're left with n squared minus n minus 600 equals 0. Which, we can factor this. It'll be n take away 25, n plus 24. And remember, if you're having trouble factoring, you can always use the quadratic formula. It's on the formula sheet. That'll give you the same 2 answers. And again, because n refers to the number of items, or in this case, number of players you're choosing from, it can't be negative. So only positive 25 would work, not negative 24. And again, we can check this. 25C2 should be 300. And it is. Okay? In how many ways can the debating club coach select a team from 6th grade 11 and 7th grade 12 students if the team just simply has 4 members? So again, the order that they're chosen doesn't matter. They're not filling specific roles. So this is again is a combination. And so the 4 members are being chosen from 6th grade 11 and 7th grade 12. So that's a total of 13 students altogether. 6th grade 11, 7th grade 12. So from the 13, you're choosing 4. It'll just be 13C4. Try that again. 715. Part B, what if they're choosing 4 members, but only one is in grade 11? So that means that one is chosen from the 6 grade 11 students. So that'll be 6C1. And then it also means that the other 3 would be chosen from the 7 grade 12. So it'll be 6C1 and times 7C3. Gives us a total of 210. Okay? So express that in factorial notation and simplify. So n minus 1 C3 would be n minus 1 factorial over n minus 1 take away 3 factorial times 3 factorial. And that is multiplied by so that is multiplied by 1 divided by n minus 2 C3. So that'll be n minus 2 factorial over n minus 2 minus 3 factorial times 3 factorial. So, we can start doing some simplifying here. You're going to have n minus 1 factorial on top of that first part. The second part, n minus 1 take away 3, will be n minus 4 factorial times the 3 factorial. And that'll be multiplied by, instead of 1 divided by, we can go 1 times the reciprocal. So the bottom, which was n minus 2 take away 3 factorial, that part becomes n minus 5 factorial times 3 factorial. And the top goes to the bottom, and that's n minus 2 factorial. Now, obviously, 1 times in those big square brackets, 1 times that expression is just the expression. So we can just forget about this 1 times part, because 1 times anything doesn't change it. Okay, so right now we can cancel the 3 factorials. Don't have to expand anything to get rid of those. We've got 1 on the top right, 1 on the bottom left. They're going to cancel. The n minus 1 factorial I will expand. The first term would be n minus 1. The second term would be 1 less, which is n minus 2. And we'll put a factorial on the end because that term or that factor is on the bottom right. So those are going to cancel. On the bottom left, I've got an n minus 4 factorial, which I'm going to expand because the next term is n minus 5. And I'll put a factorial on the end of that because we've got an n minus 5 factorial on the top right. So now, the n minus 2 factorials cancel, the n minus 5 factorials cancel. And we are left with n minus 1 over n minus 4. That's it. We've simplified it. Once again, you could check that by choosing any value of n. It just has to be greater than or equal to 5, it looks like. Because on the bottom right, when n is 5, 5 minus 2 would give you 3. That's the smallest number that you can have in front of the NC3. Okay, so that was part A done. Part B, solve for n if 720 times NC5 equals n plus 1 P5. So that right side involves permutations, not combinations. So 720 times NC5 is n factorial over n minus 5 factorial times 5 factorial. And that must equal n plus 1 P5, which would be n plus 1 factorial over n plus 1 take away 5 factorial. Right, in this case, we're using the NPR formula, which does not have the extra factor of r factorial on the bottom. The only thing on the bottom is n minus r factorial. So I'm going to cross multiply, which will give me 720 n factorial. On the bottom right, n plus 1 take away 5 would be n minus 4 factorial. And that must equal n minus 5 factorial times 5 factorial times n plus 1 factorial. So you should recognize that the left side is 720. The n factorial, there's nothing you can do with that, but the n minus 4 factorial I would expand. After n minus 4, the next term would be n minus 5, which I'm going to put a factorial on the end because I have an n minus 5 factorial on the right side. I've also got an n plus 1 factorial on the right side. So I'm going to expand that one. The next one after n plus 1 factorial will just be n, which I'll stop and put a factorial on that one because I have an n factorial on the left side. So the n minus 5 factorials cancel. The n factorials cancel. We are left with 720 times n minus 4 equals 5 factorial times n plus 1. 5 factorial is 120. So if I divide both sides by 120, or if I divide both sides by 5 factorial, that's going to simplify things a bit more. 720 divided by 120 is 6. So this gives us 6 bracket n minus 4 equals n plus 1. And now I can solve for n. I'll get 6n take away 24 equals n plus 1. So 5n will equal 25, and n will equal 5. So there's our final simplified answer. Let's do this one. Solve this algebraically. N minus 2 c n minus 4 equals 78. So if we use the NCR formula again, it's n factorial over n minus r factorial times r factorial. This will give us n minus 2 factorial. So that's the n factorial part. Remember, n's what's in front of the c. When I do the n minus r, I'm going to introduce an extra set of brackets here because we have to subtract all of the n minus 4 from the n minus 2. So that part there just represents the n minus r factorial. And that's followed by r factorial, or n minus 4 factorial. Now on the bottom, when we remove the brackets, those rounded brackets inside, it changes all the signs inside. So this n on the n minus 4 is going to become a minus n. You're going to have n take away n, they're going to cancel, and then you'll have negative 2 plus 4, and maybe I should write that out just so there's no confusion. That's what it'll look like. When you remove the brackets inside the big square brackets, the negative sign in front of that second bracket changes all the signs inside. So we are left with n minus 2 factorial all over. Again, the n's cancel here, and negative 2 plus 4 is 2 factorial times n minus 4 factorial equals 78 on the right. I would expand the n minus 2 factorial because the next term would be n minus 3 and then n minus 4, which is where we would stop and put a factorial on the end because there's an n minus 4 factorial on the bottom. I would also multiply both sides by 2 factorial, which is just 2. So on the right side, 78 times 2 is 156. So the n minus 4 factorials cancel. If we multiply out these two binomials, you're going to get n squared, take away 5n, plus 6 equals 156. Or n squared, take away 5n, minus 150 equals 0. We factor it, and the only possible answer is the positive root. Sorry, that's not right factors. It should be n minus 15, n plus 10. N minus 15, n plus 10, which gives us n equaling 15. Okay? So if you want to work on those questions, you can. I will post the solutions to Google Classroom so you can check your work. But you probably want to be focusing on that chapters 9 through 11 review assignment I gave you today. That is due Wednesday. It'll count as your unit exam for this unit, but only half weighting. Because obviously it's open book. You're going to be able to use your notes, phone a friend, whatever. So I'm not weighting it as a full exam, but half of an exam. Remember that your diploma exam is Friday morning here, 8:30 a.m. I'm sorry, Thursday. Thank you. Thursday, 8:30 a.m. Yeah. Okay?